Hi, Assalamualaikum. My name is Nurul Azmira binti Azmi, student ID 2024238578.
Assalamualaikum. My name is Nurfardana binti Shahrul. My student ID is 2024232834.
Assalamualaikum, my name is Nushasha Idina binti Muhammad Azad, student ID 2024289874.
Hello, my name is Ain Zulaika binti Aidin, student ID 2024236834.
Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. In calculus, differentiation is one of the main concepts along with integration. It is the process of finding the derivative of a function which represents the instantaneous rate of change of a quantity with respect to one of its variables. Next, what are the techniques of differentiation? The techniques of differentiation is the methods and rules used to find the derivative of x. So the first one is power rule. We need to bring down the exponent, which is the power of x, and then multiply the function by the exponent and subtract 1 from the exponent. Second is derivative of constant. If you have a constant function, then the derivative is always 0. Third one is derivative of linear. To find the derivative of linear, we use the power rule and the derivative of a constant. Next is the product rule. We use product rule when the product consists of two functions. And then we use this formula, which is dy over dx equivalent to u times v prime plus v times u prime. Next one is quotient rule. We use quotient rule when you have one function divided by another. And the formula that we use is dy over dx equivalent to v times u prime minus u times v prime divided by v square. Next is derivative of sums and difference. If you have two functions added together, like f in bracket s equivalent to g in bracket s minus h in bracket s, then the derivative of the whole thing is just the sum of the derivative. Next one is the chain rule. You use the chain rule when you see one function applied to another function. So we need to differentiate the outer function first and then multiply it by the derivative of the inner function. Next is implicit differentiation. You use it when you have an equation where y is not isolated. And the last one is linear approximation. Linear approximation uses the tangent line at a point to estimate the value of function near that point. Now let's look at question 2a. We are asked to find derivative of y equivalent to 3x squared secant in bracket s plus 2. This function is the product of two expressions. So we can let u equivalent to 3x squared and let v equivalent to secant in bracket s plus 2. Since this is a product of two functions, we will apply the product rule. The formula of product rule is dy over ds equivalent to u prime times v plus u times v prime. So we need to find the derivative of u and v separately first. So let's differentiate each part. So to find the u prime, we need to bring down the exponent, which is 2, and then times with 3, and the answer is 6. And then subtract 1 from the exponent. So the final answer for u prime is 6x. Okay, since v equivalents secant in bracket s plus 2, the v prime is equivalent to secant in bracket s plus 2 tan in bracket s plus 2. So now plug everything into a product rule. And then the final answer for the equation is dy over ds equivalent to 6x secant in bracket s plus 2 plus 3x squared secant in bracket s plus 2 tan in bracket s plus 2.
Now let's take a look at question 2b, where we will have to find dy over dx for the following function, which is y is equals to 4x plus 2 over cos x. There are two major steps in order to solve this question. Firstly, we will need to identify u, v, u prime and v prime, which is in this question, u is equals to 4x plus 2 and v is equals to cos x. And their respective derivatives would be u prime is equals to 4 and v prime is equals to negative sin x. The second step is to apply the quotient rule formula because this question involves two divisible functions, and the quotient rule formula is dy over dx is equals to vu prime minus uv prime over v squared. After applying, we will get dy over dx is equals to cos x times 4 minus 4x plus 2 in a bracket times negative sin x over cos x in a bracket square. After expanding, we will get dy over dx is equals to 4 cos x minus negative 4 sin x negative 4x sine x minus 2 sine x in a bracket over cos x squared. Now, after expanding, we can simplify the signs inside the function. Dy over dx is equals to 4 cos x plus 4x sin x plus 2 sin x over cos square x. Therefore, the final answer for this question would be dy over dx is equals to 4 cos x plus 4x plus 2 in a bracket sin x over cos square x.
On to the third question, we'll solve this implicit differentiation problem step by step. Here's the equation that we're working with. Y in 3x minus e over the power of bracket 2x plus 1 plus bracket minus 10 for y equals to 0. The goal here is to find dy over dx. First of all, we'll separate each term to make it easier and not as confusing. For the first term, which is y in 3x, we'll need to use product rule, which is u times v prime plus v times u prime. The u is y, u prime is dy over dx, v is in 3x, v prime is 1 over x. Now we put those numbers into the product rule, getting this equation, y times bracket y over x close bracket plus in 3x times dy over dx. After that, we'll solve it, thus getting the derivative, dy over dx in 3x plus bracket y over x close bracket. Moving on to the second term, negative e over the power of bracket 2x plus 1 close bracket. The derivative of e over the power of u is e to the power of u times u prime. So minus e over the power of 2x plus 1 times 2 would be negative 2e to the power of 2x plus 1. Finally, the last term, negative tan for y. Here, y is inside tan, so we'll need to use chain rule. Fx equals to g prime times hx times h prime x. There's two functions, which is why we're using this equation. Our g is negative tan and our h is 4y. Differentiate them and we'll get negative sec over the power of 2 and 4 dy over dx. Putting these numbers into the chain rule, so we'll get negative sec over the power of 2 4y times 4 dy over dx. Solve it and we will get negative 4 sec the power of 2 4y times dy over dx. Now substitute all derivatives into original equation. Dy over dx in 3x plus open bracket y over x close bracket negative 2e to the power of 2x plus 1 negative 4 sec over the power of 2 4y dy over dx equals to 0. Now we'll group the dy over dx terms and move the rest to the other side. Dy over dx in 3x minus 4 sec over the power of 2 4y dy over dx equals to 2e to the power of 2x plus 1 negative 4 negative y over x. So we'll factor it, so it becomes dy over dx in 3x minus 4 sec over the power of 2 4y equals to 2e to the power of 2x plus 1 minus y over x. Finally, solve for dy over dx. Dy over dx equals to 2e to the power of 2x plus 1 minus y over x divided by the power of in 3x minus 4 sec the power of 2 4y. And that's our solution. The derivative is dy over dx equals to open bracket 2e to the power of 2x plus 1 minus y over x close bracket over in 3x minus 4 sec over the power of 2 4y.
Okay, move on to the last question. Use linear approximation to estimate the value of fourth root of 80.99 minus 2 over square root of 80.99. Correct to 3 decimal places. Okay, to solve this question, we need to use 3 steps. First is to identify the x, x0 and delta x. X is the number in question. X0 is the nearest number from given number. Delta x is x minus x0. Second is to create a function, and the last one is to apply the formula, which is f x0 minus delta x approximate to f x0 plus 5 prime x times delta x. As mentioned earlier, we need to identify the x, x0 and the delta x first. So in these questions, the x is 80.99, x0 is 81, while the delta x is 80.99 minus 81, and then you will get negative 0.01. Second is to create a function. You need to substitute the x0 into the function, and then it will become f x0 equals to fourth root of x0 minus 2 over square root of x0. Okay, we need to change the fourth root and square root into power of 1 over 4 and power of 1 over 2. The function will be x naught power of 1 over 4 minus 2 over x naught power of 1 over 2. And then bring up the denominator, and then you will get x naught 1 over 4 minus 2 times x naught power of negative 1 over 2. Next is to find f prime x naught. To find f prime x naught, you need to differentiate the function. So, after you differentiate, you will get 1 over 4 times with x naught power of 3 over 4 minus negative 1 over x naught power of 3 over 2. And what you need to do is to change back the power of 3 over 4 and 3 over 2 into the fourth root and square root. And then final answer will be 1 over 4 bracket fourth root of x naught power of 3 plus with 1 over 4 square root of x naught power of 3. Okay, lastly is to apply the formula, which is f x naught plus delta x approximate to f x naught plus f prime x naught times with delta x. Substitute all the information into its places, and then you will get bracket fourth root of 81 minus 2 over square root of 81 plus bracket 1 over 4 bracket fourth root of 81 power of 3 plus 1 over square root of 81 power of 3 times with negative 0.01. And then you calculate all the value, you will get bracket 3 minus 2 over 9 plus bracket 1 over 108 plus 1 over 729 times with negative 0.01. Next, you will get 25 over 9 plus negative 31 over 261,600. And then you plus the two value, the final answer will be 2.778. You need to make sure the final answer is correct to 3 decimal places.